Welcome, everybody. Chapter 1.1, talking about solving simple equations. First, we're going to talk about a little bit of vocabulary. This vocabulary will be talked about throughout the rest of the year, especially this chapter, and you could find it on some of our quizzes and tests. Let's start with an equation. An equation is a statement that two expressions are equal. An example of that would be 2x is equal to 4. A linear equation in one variable is an equation that can be written as ax plus b is equal to 0. A and b are any number you want, and then x is the variable. I like to say that another way to recognize this is there is only one letter or type of letter in the problem. So there's only X's, or there's only A's, or there's only Y's, or there's only R's, or whatever the variable is, but that's all there is. So you're not going to have like 7R plus 2Q. That would be two variables. A solution is a value that makes the equation true. So in our 2x equals 4, the solution to that would be x is equal to 2. 2 times 2 is equal to 4. Yep, that's true. Inverse operations are two operations that are opposite or undo each other. So the most common ones that we've learned so far are that adding and subtracting are inverse operations, and multiplying and dividing are inverse or opposite operations. And then last but not least, equivalent equations are equations that have the same solution. So 2x equals 4 and 3x plus 2 is equal to 8. Both have a solution of x is equal to 2. And we'll talk about more on equivalent equations when we get into class. All right. So we have two properties we want to discuss today: the addition property of equality and the subtraction property of equality. So basically, the addition property of equality means that we are adding the same thing, the same value, to both sides of an equation. What this looks like in algebra terms is if we have A is equal to B and we add C, then A plus C should equal B plus C. Or, to put some numbers with that, if I have X is equal to 4, then X plus 2 would be the same as 4 plus 2. Subtraction property of equality is the same thing, only we're subtracting instead of adding. So subtracting the same value from both sides of the equation. Again, if we're looking at the algebra way, then that would be if we subtract C on both sides, then they're still equal. Or we can put, if we have R is equal to 7, then R minus 2 is the same as 7 minus 2. All right, let's use some of this to get going on some problems here. So our first two examples, x minus 3. So the inverse or opposite operation of subtraction is addition. So if we add 3 to both sides, minus 3 plus 3, they're opposites. They add to 0. We don't have to write 0 down, so we have x left on that left side. And then on the right side, we do negative 5 plus 3, which is negative 2. Now, of course, we always want to talk about checking our work. So we plug negative 2 in for x. So where we had x minus 3, we now put negative 2 minus 3. Negative 2 minus 3 more. Or say I owe 2 and then I'm borrowing 3 more. So I owe a total of 5. And are those exactly the same? They are. So we're good. Let's try the second one. We have y plus 2.8. So the opposite of adding, or the inverse of adding, is subtracting. We're subtracting 2.8 from both sides. 2.8 minus 2.8 is 0. So we're left with y on the right side. And then 0.9 minus 2.8 is negative 1.9. And then, of course, we can always check our work to make sure that everything works out the way we wanted it to, especially if you happen to be like me and sometimes I forget to write the negative. Oops, it happens. We don't like it, but it does happen. So negative 1.9 plus 2.8 is 0.9. So does 0.9 equal 0.9? Yes, it does. All right. So in your notes for class tomorrow, do 3, 4, and 5. And we're moving on to the next page. Multiplication and division. These two properties of equality are the same as the addition and subtraction. So what they mean is for multiplication, we are multiplying the same value on both sides of the equation. Meaning, again, we're going to show the algebra way, where if we multiply a times c and b times c, they should equal the same thing. So if we have x is equal to 7, then if we did 2 times x and 2 times 7, they should equal the same value. Division property of equality is dividing both sides of the equation by the same value. Again, with our a and b, a over c and b over c would have to be the same thing. Where if I had, let's say q equals 4, and I divided both by 4, then they should both be the same value. All right, let's do some math with that. So we have negative n over 5 equals negative 3. So right now we're dividing n by 5. Now it's our choice if we want to leave the negative and deal with it later or just take care of it all at one time. I recommend taking care of it all at one time. So what that means is I'm going to take this and I'm going to multiply by negative 5 over 1. And whatever I do to one side, I have to do to the other. Now remember, I can make anything into a fraction by putting it over a 1. So how does this help us? Well, if you remember a little bit about simplifying fractions, then these negative 5s, because 1 is in the numerator and 1's in the denominator, or top and bottom, we can cross-reduce them, and that leaves us with 1. So 1 times n is 1n. And then over here on the right, negative 3 times negative 5 is positive 15. Of course, we can do a check and say, all right, if I have that negative, I replace n with the 15. So negative 15 divided by 5, is that equal to 3? Yes, it is. So our answer is good. Number 7 looks a little weird. We have this funny symbol pi. So I want to get x alone. Right now I'm multiplying x by pi. The opposite of multiplying is dividing by pi. So pi over pi simplifies to 1. So we have 1x. And pi over pi here reduces to 1. Negative 2 times 1 is negative 2. So we've solved our equation. We have x is equal to negative 2. Number 8. This is 1.3 times z. The opposite of multiplying is dividing. So we're dividing both sides by 1.3. Now remember, 1.3 divided by 1.3 is 1. So that leaves us with 1z, which we can just leave as z. And then 5.2 divided by 3 is 4. And if you needed to use your calculator for that, that's absolutely okay. So you have 9, 10, and 11. Want you right now to work on that. Pause this, work on those. Jot down any questions you might have for class tomorrow. Okay. Solving real life word problems. Love word problems. I know sometimes they can be a little scary, but we're going to work on them this year until they're hopefully not very much or not at all anymore. So we're going to try to first understand the problem. What are they asking you? What is unknown? What are you trying to get towards? I always like to go to the very last part of the problem and look at the question and then go back and read the problem so I know what they're giving me. Step 2, make a plan. How are you going to solve this problem? Are you going to make a diagram? Are you going to, so let me try to fix that, obviously. Can't spell very well there. Silly. Plan. Maybe you don't need to write an equation. Maybe you want to make a table. Maybe you want to draw a picture. Maybe you want to make a tree diagram. I don't know. There's lots of different ways to solve these sometimes. The third step, you're going to solve the problem that you came up with. Find out what the answer to the question is. And then the biggest part of this whole entire thing is this last step. Look back. Does your answer make sense? For example, if they're asking how many cars can possibly be parked in your driveway and you get an answer of 279 cars, probably not reasonable. Maybe I made a mistake somewhere. It's possible, right? Or let's say that you wanted to know how many pies you needed to bake for a bake sale to help out the swim team. And you somehow came up with a negative 29. I don't think it's going to be negative. Let's go back and double check that. Mistakes happen. we love mistakes. Mistakes are how we learn. So just make sure we go back and figure out where that mistake takes us. So we're going to talk about some possible strategies that you used and then other ones that other people use tomorrow in class. So we're going to leave that top part of the next page blank for now. And let's go on to our last two examples. So we're starting here with the Olympics. And I'm going and saying, write and solve an equation to find his average speed. That's my task, find his average speed. So I'm also seeing meters per second. Well, that's going to help me, meters per second. And I see that Mr. Bolt went 200 meters in 19.32 seconds. Oh, well, now I can simplify that, and that should give me my answer. So 200 divided by 19.32 gives me roughly about 10.35 meters per second for the average speed. And that seems pretty reasonable, right? If you did 200 meters in 19 seconds, that's I could never do that, that's for sure. All right, number 13 here. How many degrees did the temperature fall? All right, so that means we're looking at from 9 a.m. to, sorry about that, I don't know what happened with that. From 9 a.m. to 9:27 a.m. So we want to know the difference in temperature. So the difference from 9:27 to 9 o'clock is -4, and it started at 54. Now the difference, we want to know because it fell, that's a difference in temperature. Difference is subtracting. So -4 minus 54 gives us -58 degrees Fahrenheit. Another thing we could do there is make a number line. And we could say, okay, I started over here at 54, and I went here to -4. So what is this difference? Well, it's a difference of 58, and since it fell, that would be negative. All right, your last task then is to complete problems 14 and 15 of the U-Try, and we'll see you in class tomorrow. Have a great day.